All right, for this bell work, we got the slope-intercept form equation y equals negative 19x minus 50. All it tells us to do is find the slope and y-intercept. And this is great news because it's already in slope-intercept form, okay, which looks something like this right here. Y equals mx plus b. So all I got to do for the slope is to find the coefficient of x, which is m, and it's in the same position as this negative 19. So that tells me that the slope is negative 19, okay? Then we got to find the y-intercept, which is just the number that's being added or subtracted to the x's, and in this case, it's this negative 50, okay? So it's not just negative 50 when you put this in as a y-intercept. It's the ordered pair 0, negative 50, because that tells us that the x value is 0 and the y value is negative 50, which is right on the y-axis, the y number line, okay? Now, just as a quick note, because we've gone over this already, the slope is negative 19, but if you were to look to graph this, like I think we did last time, right? The negative would tell you to go down 19, and then, yeah, we made it over 1. That's so we can see the rise and the run. Down 19 and then to the right 1. Okay, well, down 19 to the right 1 from where? That's where this ordered pair comes from. It comes in from 0, negative 50, you'd go down 19 to the right 1, and that gives you the next point. Here's our objective for the day. I can write the equation of a line in slope-intercept form. Take 30 seconds and copy that down, please. Yeah, on that last assignment, they gave us the equation, and then we made the graph, right? So that's when we were looking at slope-intercept form, like we're doing today again, which is just like this: y equals mx plus b. M is the slope, that's the coefficient of x, and b is the y-intercept, okay? It's just now what they're going to do is give us the graph, then we got to write the equation. But this is the only two pieces of information that you will need in order to write any equation for a straight line. All you need is the slope, and then you need the y-intercept. That is all, okay? So when we find the slope, you can always use the slope formula like we've been doing. Remember, it's always subtraction between the two values. There we go. And the x values are in the denominators, y is in the numerators for both ordered pairs. Okay, so this is an ordered pair here, and then this is the second ordered pair. Doesn't matter which one you put first or second, it's going to give you the same slope no matter what. Okay, and then that gives you the slope. The y-intercept, the nice thing about the y-intercept is that it is just a visual check. All you got to do is look at the graph, see where it goes through the y-intercept, boom, you're done. So even though this is the only two pieces of information you need to write the equation, and the second piece here is the y-intercept, but it's true that any point will do. That brings up a different scenario that we'd have to solve for the y-intercept, which we will be doing later. Okay, but today they will give us the slope and the y-intercept in every problem. So we're not actually define the y-intercept as a fractional value or decimal value. But again, the y-intercept, the nice thing about the y-intercept is it's just a visual check. All you're doing, right, because you got the two axes here, you got the x-axis and the y-axis like this. But whatever line you get like this, all you're doing is seeing, just look visually and see where does that line go through the y-axis. Remember, this y-axis is straight up and down like this, so it has to go through that y number line, okay? After that, all you need is one other ordered pair, and then you can find the slope, which we've been doing. In fact, yeah, it seems like we've been able to find slope from the last unit when they gave us two ordered pairs, no graphs. Of course, we need to be able to do it with the graph as well, but either way. So on a graph, yeah, you can use the slope formula, but you can also use the stair-step thing in order to figure out the slope too. Okay, so all we're doing right here is kind of warming this up. And so we say, hey, look, we got this format, y equals mx plus b. All right, and really all we're doing is filling in blanks right here. If we can just figure out the slope and the y-intercept. Well, they gave us up here the slope at negative 8/9. Okay, so that means that where the slope is, yeah, I'm gonna put a negative 8/9 in there. Okay, so I get negative 8/9 right there. That's all I got to do for now. But then they also gave us the y-intercept. Okay, and that's important information for us too. Okay, because the y-intercept, that's the plus b part of the formula. So I just replace the y-intercept. Now it's not the whole ordered pair that goes in. It's just the y value. That shows as negative 7. Now I showed as negative 7 right here, even though in the problem itself it would read minus 7. Okay, so this right here, y equals negative 8/9 x minus 7, that is the slope-intercept form of the equation of the line that has slope of negative 8/9 and y-intercept of 0, 7. So we're going to do the same thing on this one. And we got to look at slope-intercept form. Y equals mx plus b. Okay, so there it is. Let's move it over here. And once again, I'm just going to set up the foundation of this equation. Y equals, and there's a blank right here that I'm going to fill in, and then we got this other blank right here that we will fill in. Okay, now the slope, they're telling us the slope right here is 17/4. So that means where my slope goes, I'm going to put 17/4. Okay, and then the y-intercept was also given to us as 0, 14.5. Now that's a decimal, which is okay. It's a positive 14.5, so I show that as plus 14.5. And that's it. That's as much as I need to do when writing this equation, okay? Now when they give us graphs, this will be only integer or whole values so that we don't have to worry about solving for what that decimal will be. If we do see any decimal values as our y-intercept, we'll have to use a different strategy in order to find it, because stinging math people, sometimes it'll look like it's halfway through, but it's actually like 0.45 the way through, because, well, sometimes math people can be jerked like that, okay? But this will do for now. All right, so we got to write the equation for this line, right? So let's go and do that. And we know that the format for the equation, it has to be in this slope-intercept form, like this, okay? So once again, we can set up the format right now. Y equals mx plus b. And then all I'm doing is filling in the two blanks right there. That's it. Because that's the only two pieces of information that I need in order to write this equation. Now, like I said, with a graph like this, it's just a visual check for your y-intercept. So that's what I'm going to solve for first. Now, I'll put it right here in the equation, okay? And I can see that this blue line is going through the y-axis. Remember, the y-axis is this vertical number line right here, right in the middle. Okay, that is the origin, which the x value is always going to be 0 for your y-intercept. It's just now the corresponding y value is also 0. So for my y-intercept, I just put the y value in there, 0. So I'm going to show that as plus 0 right there, okay? And that's good. So I've got my y-intercept. That's one of the two pieces of information I need. All I need now is a slope. Okay, so I'm going to use the slope formula first, but I'm going to show you that using the graph will work as well. And so we got to find some other ordered pair to use. And remember, we have to find where the ordered pair is right on an intersection. We do not want any decimal values in our ordered pair. So I see that it's possible that we could have used this one right here, or this one, or this one, or this one, okay? Those ones are right directly on those intersections. So doesn't matter which one you use, you get to choose. And since we've already chosen the y-intercept, you know what, I'll choose this one over here. Now remember, it does not matter which one of these you would have chosen, you'll get the same exact y-intercept, okay? Or the same slope. So that is an x value that's -2, and then the y value here is -4. -2, -4, okay? So I'll start with my purple ordered pair, right? So I got an x value that's 0, and I know that the x value goes in the denominator. So I'll put a 0 there. Then the y value here is 0, and the y value goes in the numerator, but it's 0, so 0. Then we have the green ordered pair, okay? So the x value here is -2. Now the x value does go into the denominator, that's for sure, but I'm still just going to put it in as -2. I don't care that there's a minus sign there, which is always will be. I'm going to keep this as minus -2 because the calculator will take care of that for me. And then in this ordered pair, the y value here is -4, so I replace the y up here at the top in the numerator with -4. And all I got to do is solve from this point. Okay, so I'm just going to go to my calculator, and I type the n over d button, 0 minus -4. Remember, the minus and negative buttons are different. Then I go to my denominator, 0 minus -2. And when I push enter, it tells me the slope here is 2. Okay, so that's my slope. And I can put that into my equation, right? Now that's using the slope formula to find the slope. Like I said before, we could have used the stair-step method in order to find the slope here. And so from the green point to the purple point, I'd have to go up to this line and then over to the right. So that shows up 1, 2, 3, 4. There's 4. Up 4, and then to the right 2. 1, 2. Okay. So up 4 to the right 2. Why does that show a slope of 2 in red then? Okay, well that's because 4 over 2 does actually equal 2, and so we get the same slope either way. It's just that the 2 here is simplified from our 4 over 2. Okay, so you would have gotten the same answer even if you used the stair-step method. And you can see here that the slope that we have there in red, if we made it 2 over 1 like this, it would have been up 2 to the right 1, and then you could have gone even from the purple point up 2, and then to the right 1. That would have given you this next ordered pair. Okay. So the slope works no matter what because it's a straight line. That's very nice. Now the last thing on this is I would recommend not putting the +0 into Canvas because it's kind of picky, like you guys saw with the last lesson, right? And so I would just kind of leave it as y equals 2x. I believe it will give you credit for the +0, but to make it really fully simplified, we would want to make that a phantom +0. It's still there, by the way. It's just not being shown, that's all. All right, so let's do the same thing on this one. Okay, so we do want slope-intercept form, that's for sure. Y equals mx plus b, okay? So I'm going to set mine up. Y equals mx plus b. And remember, the slope is the coefficient of x, so it goes right in front of the x, and then the y-intercept there is whatever we're going to add or subtract to this. And yes, we are looking at a graph, which means that the y-intercept is just a visual check, okay? And be careful not to use these kind of false points right here, because some students say this is going through 0, 3. It's not. That line is not right on that intersection. Same with down here, this one. Yeah, it's pretty close, it's just not right there, or this one. Okay, you got to find where it goes exactly through those intersections, and I see that this one is going through this ordered pair at, remember the x value is always 0, and here the y value then is 4. Now we don't put the ordered pair in the equation, we just put the +4 right here, okay, the y value. Now that I have that, which was nice, just a visual check, all we have to do is see it. Now we're ready to put the slope in, okay? So remember, it's always subtraction between the x's and y's. Okay, and I know that my x's will be in the denominators, y's in the numerators, for both ordered pairs. Okay, I just got to figure out what they are. Then we will put it in the calculator, and then it will solve it for us, okay? So I do have the 0, 4, which is great. And so the x value is 0, the y value is 4. That's good. And we can put that in right now. X value is 0 in the denominator, y value is 4 in the numerator. But we need some other ordered pair, and like we've kind of already scanned that blue line, it's going through this ordered pair right here, which is at 1, -3. Okay? So again, do not use 1, -2 or 1, -4. Those are not correct ordered pairs to use. But I can see on my green ordered pair then that the x value is 1 and the y value is -3, so I'm ready to put these into my slope formula. The x value is 1, it goes in the denominator. The y value is -3, so it goes in the numerator. Again, this 3 being negative isn't going to mess with this minus sign unless you want to use keep change, which you're doing it manually. That's fine, but I'm just going to put it in the calculator as 4 minus -3. So I go to my calculator, n over d, 4 minus -3, all over 0 minus 1, and this shows me -7. So that is the slope. -7, that would do. That would do for us, okay? But just in case you're using the stair-step method to find the slope, which is fine, you can see that you'd have to go, looks like down, let's see how far down that is, 1, 2, 3, 4, 5, 6, 7, and for those of you that understand the slope, you should have expected that from the -7 right there, and then you would have went to the right one, okay, which is what we do. The right one, okay? So that would have given you -7 over 1. Just make that divide by 1 or over 1, a phantom 1, when you put it into the equation, okay? Y equals -7x plus 4. That is all. Now, something else I just want to emphasize real quick is even though this is only showing 2 ordered pairs, okay? On that last problem, we had like 5 different ordered pairs that we could have used. But this one only has 2. That's what this means, the ordered pairs. Just remember that this means that this x value and this y value, this purple one, if you replace this x value with 0 and this y value with 4, you get a true statement, okay? Same with the green ordered pair. If you replace x with 1 and the y value with -3, you still get a true statement. That's what all the ordered pairs on this blue line are telling you. And there's so many that it's better just to show it with the equation or graph because we don't want to list all these, especially the decimals. There's an infinite number of decimals. And then it extends forever as well. All right, here's this one. You guys try this one out. Try this one out. See if you can find your slope and y-intercept and then make your equation in slope-intercept form, okay? 1 minute, go. So as usual, this is a graph, so I just need to quickly look and see where my y-intercept is. I see the blue line going through the y-axis right here. That's at 0, 2. Okay, so remember, your x value is always 0. Just figure out what your y value is, okay? And I see that the y value is positive 2, so I show this in the equation as plus 2. So I only need one other ordered pair to use in order to find the slope. And there's 2 to choose from. You could have used the -4, 1 here, or you could have used 4, 3 here. And like I said before, it doesn't really matter which one you choose to use. -4, 1 here, or 4, 3. I'm going to choose to use 4, 3. Really because both values are positive. It doesn't matter though, right? Because we're going to be letting the calculator do the work for us, okay? So I'll just get this one out of sight, out of mind, okay? Let's not look at that one. And remembering that it's the x values in the denominators, y is in the numerator for both ordered pairs. And this should give us a slope. Okay, I'll start with the purple one, where the x value is 0 and then the y value is 2. Okay, so x in the denominator, it is 0, and the y value is 2, it goes in the numerator. 0, 2. There's our ordered pair in purple. And then we have the green ordered pair where the x value is 4 and the y value is 3. So x value 4 goes in the denominator, y value 3 goes in the numerator. All I got to do here now is just push this in the calculator. So n over d, 2 minus 3, all over 0 minus 4, and I get positive 1/4. Okay? So I'll put that in as my slope, 1/4, and that would do it for the equation. Okay? Now, again, I'm going to show you that you could have used the graph to find the slope. You would have went up and then to the right to get from the purple to the green point. So how far up is that? Well, it's 1 box, so it's up 1, and then to the right 1, 2, 3, 4, to the right 4, okay? And that's pretty much what the slope is showing us in red there. It's up 1, and then to the right 4. It's the same thing. Okay, so there's our slope in 2 different ways. You only have to do it one way, of course, but you can do it both ways if you need to. But we had to use both ordered pairs. Now, just like we saw in Unit 4, is we need to be able to find the slope even though they may not give us the graph. If they do, then they have to give us the ordered pairs, of course. But if we only have 2 ordered pairs, we can find the slope from this formula. So we got some word problems that you're going to see on the assignment as well, okay? However, this one says that it still wants the equation in slope-intercept form. So what does slope-intercept form look like? Y equals mx plus b. There it is. Let's read this, though, so we can figure out what we're looking for. So Allie goes to the carnival. It costs $7.50 to get in, and then $1.25 per ride. Yeah, I'm going to write this in slope-intercept form, okay? Now, the slope in a word problem, at least, I'm not saying that you'll remember this from 7th grade because no one remembers jack squat from 7th grade, but the slope is also known as rate of change, okay? So that's what something like that they would have said in 7th grade. Really, the only thing we're looking for here is the rate, okay? If you can just find the rate, then you will know the slope. The y-intercept, on the other hand, is That's going to be like some kind of starting value here. From time to time, you'll see problems where it's more like some kind of fee, some kind of starting value, okay? And if you can find that in these equations, then you'll be in good shape. All right, so my equation will be in the same format, y equals mx plus b. I just got to find the slope and y-intercept. Now, the slope, like I said, is a rate. Did they give us a rate? Well, since we don't remember 7th grade, what the crap is a rate? A rate is a comparison of two different quantities. In this one, we're looking at dollars and rides. It's right here, okay? They were comparing dollars and rides. Usually, if you're looking for the rate, you're looking for this word right here, per, maybe for every, something like that. So maybe an ride, something like that, yeah. You can see that it's a comparison. You have something per something else. And for those of you that remember 7th grade, now there's many people that do, this is what we call a unit rate, in fact, because it's per one ride. Remember, that's where one of the comparisons in the rate is 1, okay? Now, none of that really matters because we were just looking for the rate. We don't care that it's a unit rate, all right? It's just a rate. Well, what is the rate? It's $1.25 per ride. $1.25, okay, well, let's put that in as our coefficient of x. That is it. Did they give us some kind of starting value or some kind of fee? Yes, they did. They said it costs $7.50 just to get in, okay? Now, what this also means is that at this carnival, if Allie doesn't go on any rides, she's still got to pay the $70.50 to get in, okay? So that's why it's kind of like a starting value, a starting fee, some kind of entry fee, something like that, okay? And that would cost her positive $7.50. Now, this is the equation right here. We just did it. But just so we understand, in this context, and we've already talked about independent and dependent variables, the amount that she pays, that's the y value, that's dollars, will depend, so that's x value, that's independent. That's how many rides that Allie goes on. If she goes on 0 rides, she'll pay $7.50. If she goes on 1 ride, she'll pay $8.75, and so forth, okay? Y is the cost, X is the number of rides in this particular situation. This one's pretty much the exact same situation as the last one, just slightly different, you know, a little bit different wording. So remember, for our y equals mx plus b, the slope is the rate of change, the rate that we're looking for, and then the y-intercept is some kind of the starting fee on this one, starting value, okay? So here's my setup, y equals mx plus b, I'll fill in this blank, and then this one right here, okay? Now, did they give us a rate on this one? They did. They said, well, I guess we should read it. Mike starts a new job as a mechanic. They're going to give him a $2,500 starting bonus and $85 an hour. There it is, $85 an hour. That is the rate comparing dollars for hours, okay? And again, it's a unit rate, 1 hour. It's $85, so I just go into my slope and I replace it with 85, boom. Okay, now again, we need 2 pieces of information to write the equation. The next piece we need is the y-intercept, some kind of starting value, and they even said it's even the starting bonus for old Mike on this one. It says that it's $2,500. Okay, it's positive because they're going to give it to him, and so we show it as plus. This is it. Okay, so just to interpret this equation, the y values that we're going to be looking at, that would be how much money Mike will make, and x right here would be how many hours he would work. The 2 variables are always described in the rate, dollars and hours, so you just got to figure out which one is which, okay? Now, of course, you know, if Mike works 0 hours, they'll probably ask for the bonus back. In real life, usually if you have some kind of starting bonus, then you're committed to working for at least like 3 months or something like that. They'll give you a contract, and if you breach the contract, then they make you pay the money back. So the equation is realistic so long as Mike meets the contract. All right, going back to the stuff that we learned last time, y equals 9/4 x minus 4. All we're looking to do on this one is to graph the equation, okay? So we have some experience doing that. All right, so there's our setup. Y equals mx plus b, y equals mx plus b. And I can see from this, just the setup right there, that the m is coefficient of x, it's 9/4, okay? So I know right now that my slope is 9/4. Okay, so even as the slope, remember it's rise over run, the 9 is positive, which means we're gonna have to go up 9. And then the denominator is positive, so that means we'd have to go to the right 4. Okay, up 9 to the right 4, but up 9 to the right 4 from where? That's where we need the y-intercept, which is showing as -4 or -4. Remember, it's an ordered pair though, so we showed as 0, -4, okay? So I just gotta put 0, -4 on the graph. So I start from the origin. It's on the y-axis, by the way. That's this vertical number line, not the x-axis. I start at the origin, I go down 4. 1, 2, 3, 4. So that is where my ordered pair 0, -4 is right here, okay? Okay, so I got that on the graph, but now from that ordered pair, I've got to go up 9 and then to the right 4. So let's see. I got to go up 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go all the way up here. So that would be up 9. And then I know I got to go to the right 4. So 1, 2, 3, 4, right? So that's to the right 4, boom. Okay, now that I have those 2 points, that's actually all I can fit on this graph anyways. So let's go and put that in, okay? And something like this. That's better. All right, that blue line is the line that represents this equation. And like I said before, we have 2 ordered pairs. We have 0, -4, and then the red one that we made there, it looks like that's at 4, 5. So I can't emphasize this enough, but 0, -4, it would make this original equation true. Same with 4, 5. If you replace the x with 4 and the y value with 5 here, you'll get a true statement there. All right, here's this one. You guys try this one out. Take a minute, try it out, and we'll go over it. So for this one, we see the setup y equals mx plus b. Okay, and this one's already set up, y equals mx plus b. That's very nice. By the way, just so you know, in the future, they're not going to give us this in slope-intercept form. We will force it to be in slope-intercept form, okay? So right here, I got the coefficient of x is mx, y equals mx plus b, and that's the -3 right there, okay? So that tells me that my slope is -3. Since I'm putting this on the graph, I'm going to show it as over 1. So I don't just want the one number, I want both in the fraction so that I can see my rise and run. It's just that since the 3 is negative, that tells us we're going to go down 3 and then to the right 1. Well, down 3 to the right 1 from where? That's where we need that y-intercept, okay? And the y-intercept is showing it's just the plus b on this. Okay, and I see that it's being plus 5 right there, okay? So, again, as y-intercept, it's not just 5, it's the ordered pair 0, 5, okay? So, for our 2 axes, we got the x-axis, the x-axis, and the y-axis. We're looking for the y-axis where the value is 5, the y number line, okay? So, I see from the origin, I'd go up 1, 2, 3, 4, 5. Boom, there it is. That would be my y-intercept right there at 0, 5. But then from there, the slope says that I got to go down 3 to the right 1. So that's what I'm going to do. I'm going to create a stair step and go down 3. And then I'm going to go to the right 1. Okay, so that'd be to the right 1. Boom. There's my next ordered pair. Make that a little bigger. There I go. But I can continue that stair step. Down 3 to the right 1. That's my next point. Down 3 to the right 1. There's the next one. And I can continue that. There's the next one. Down 3 to the right 1. Okay. And since I'm doing this by hand, I'm going to go left 1 up 3 as well from the y-intercept, just so I can see all the points. Okay, so now that I have this, I am now ready to graph this. So I'm just going to put a line through all these ordered pairs, okay? And a couple arrows on that line. Now remember, when you put this into Canvas, you only need two ordered pairs. And usually it's just the first one that you put in there is the y-intercept and then the second one. If you put any more points there in Canvas, it will mark these graphs incorrect. Just like you saw in 5.1, okay? So in Canvas, you're going to choose the line function and then just put your points on there. It will create the line for you Only when you're doing it by hand would I recommend putting all the points in there like I did. But there's the objective for the day. I can write equation of a line in slope-intercept form, which is y equals mx plus b. So get used to this old y equals mx plus b stuff, because it's not going away anytime soon. And it's so important that the ninth grade teachers, if you don't know how to do this stuff, then they kind of freak out too. So learn it and make a ninth grade math teacher happy. I feel like I gave you a reason not to do it, but whatever.